So a trig identity is something that relates trig ratios, trig equations, and it's always true. And you already know a couple of trig identities. So later on here, I mean, you've already learned that sine is your x-coordinate, sine is your y-coordinate, cos is your x-coordinate, and so on. But we've already learned these first identities. You know that cosecant is 1 over sine. You know that secant is 1 over cos. And you know that cotangent is 1 over tangent. You also know that tangent is sine over cos, and cotangent is cos over sine. This part that they write in right after, I'll underline these parts in red, are just stating that sometimes these identities don't work because if sine was equal to 0, then it would have a non-permissible value. So all of those parts in red are just telling you about non-permissible values. What I would like you to add beside here is that if you know that cosecant is 1 over sine, you also know that sine is 1 over cosecant, and that cos is 1 over secant, and tangent is 1 over cotangent. So when things are reciprocals, it works both ways. So you can rearrange them that way, and underneath here, they have some other rearrangements as well. Can you see how you could rearrange those equations? That first one, cosecant is 1 over sine, so if you multiplied both sides by sine, you have that cosecant times sine is equal to 1. Is on this identity sheet, we're going to learn some of the sort of the formatting rules that we're going to use for identities, and we're going to learn what it means to solve an identity. So what we had here as a starting point, these are the tools that we have so far. And as we continue on this unit, we develop more tools. So the way that it works is you have these reciprocal identities, these quotient identities. These are our tools so far. And with them, we want to prove some new ones. So for example, number 5 on your sheet says secant t cos t equals 1. So what you're going to do when you're asked to prove something, and this one is a very basic one. In fact, you could even say it's one of our tools already because we highlighted it. But we're going to use this very simple one with just the reciprocal identities that we have to show a proof. So when you're trying to prove something, you're going to always rewrite the equation out. After you rewrite the equation, you're going to draw a line at the equal sign. So this is the formatting part. With that line at the equal sign, you are now allowed to use your tools, and it's sort of a puzzle, and you want to make both the left side of the line and the right side of the line exactly the same. So what you do is you look and you say, is there something I could change? Do I have a reciprocal identity that I could change either cos or secant to something else? Well, yes. What could I change secant to? I could change it to 1 over cos. If I changed secant to 1 over cos, now I'm going to use my fraction rules. What am I doing here? I'm multiplying. Can I write this as a single fraction? Well, I would multiply the tops and I'd multiply the bottoms. At this point, you might be already see that you're done. I'm going to do the extra step here. Most of you probably won't write out this extra step. But if I multiplied, oh, what's 1 times cos t? It's cos t. Oh, what's 1 times cos t? Oh, it's cos t. And what is this in simplified, most simplest form? What is cos t divided by cos t? 1. And at this point, you see that your left side of the line is 1. What was our right side of our line? It's also 1. We have finished. This is what proving an identity means. We try to get the left side and the right side identical. Once we've done that, the last formatting thing that we're going to do, we write a statement to say that we're finished. 3 dots means therefore. The left side is equal to the right side. Okay? And now I like to add a little personal couple things to this to make it fancy. A lot of mathematical proofs, when they're done, have a statement, QED. My Latin is terrible, but it stands for something like quod erat demonstratum, which is probably, I pronounced some of that terribly, which means in Latin, what has been asked for has been shown, or what has been asked for has been demonstrated. And then, for me personally, I always like to do one little, make up some other symbol. I like to do a little shaded box, so that I'm done. You can make up your own little symbol, or you don't have to do anything at all, but it's just kind of fun. So you need to say that the left side's equal to the right side to show that you've finished. Make it nice like a mathematical proof and add QED. And if you want to add something else to the end, you can. So this one was really straightforward because we just had to change one little thing to make it the same. Okay? We're going to do 2 more together, and then I'm going to get you to try a couple of these. So the next one that we're going to try together is cos y cosecant y. This is number 9. So again, always rewrite the equation. Draw your line. And then the puzzle starts. Now, often you're not going to be able to see right away what you should change, so you just change something. If I look on the left side, I could change cos y to 1 over secant if I wanted. I could change cosecant y to 1 over sine. Those are things that I could change them to. They're in my toolbox. Which one would you like to change? Would you like to change cos to 1 over secant, or would you like to change cosecant to 1 over sine? Cosecant to 1 over sine. And you're going to find this because are you more comfortable working with cos and sine or cosecant and secant? Probably you're more used to using cosine and sine. So one of the strategies that you sort of develop is, hey, I can change things to sine and cos, and that might make things easier. So here, I change cosecant to 1 over sine. How about on my right-hand side? Can I change cotangent to anything? Yes, I could change it to 2 different things. Cotangent is 1 over tangent, and cotangent is also cos over sine. Which of those would you prefer to do? Cos over sine. So what's different in this one is I decided to work on both sides of my equation. How do I multiply fractions together? Well, this is over 1. Multiply the tops and multiply the bottoms. Can you see that they're identical? Therefore, the left side is equal to the right side. Very nice. And we're done. Not too bad, right? Didn't see how this was going to work necessarily right from the beginning, but then we went and changed something. And we changed something that we could easily change. And here we sort of were introduced to the strategy of, hey, I could change something to sine and cos. And if everything's in sine and cos, then there's a good chance that they're going to equal each other. That being said, these identities or these proofs of these identities have many different ways to solve them. This would have also been right if you decided to do nothing on the right-hand side of the equation, and when you got to cos over sine, you decided, hey, cos over sine is equal to cotangent. That would be another way that you make your left and your right side the same. So you have some choice, but in the end, your goal is to manipulate one side at a time to get them to be equal. What you're not allowed to do is you're not allowed to move things over this line. It's not an equation. You're trying to prove that it's true, but until you've proven it, you can't assume that it's true. So you would not be allowed to, for example, say, multiply both sides by sine. You can only work on one side at a time, and working on both the sides until you get them identical. So we're going to do one more together. Whoops. We're going to do number 14 together because there was a typo in that one. So we have sine u over cosecant u plus cos u over secant u equals 1. So again, we rewrite the equation, draw our line, and what can we change? Well, if we use that strategy we had before and we change things to sine and cos, what can I change cosecant to? I can change it to 1 over sine u. Here I have cos. What can I change secant to? 1 over cos u. Again, a couple of things are going to happen in these identities. One, you're going to have fractions inside of fractions, and you're going to write one thing underneath another thing and work as you're going. So some things to help you not get confused. First of all, use space, right? I have a space in here so I don't get confused with one fraction leading into another fraction. Okay? Like I said before, I have extra paper. If you're worried about saving loose leaf, I will give you loose leaf. Okay? So use some space to separate things. Secondly, notice how I used thicker lines here and thinner lines there so I could tell where was the middle of my original fraction. Because this is a totally different thing if, and I mean, if I wrote, this is totally different than this. These are not the same. So I should erase the bottom one. So I want to make sure I know where my original fraction was. Because now at this point, what do I have? I have a fraction divided by a fraction, and another fraction divided by a fraction. My goal here is to write things as a single fraction, just like we were doing at the beginning, because if I can do that, chances are I might get close to being able to solve this. So for the first one, how do I do a fraction divided by a fraction? Multiply by the reciprocal. Can you see that the top of my fraction is just sine u over 1? And if I multiply by the reciprocal, I'm going to multiply by sine u over 1. Plus, same thing here, top is cos u over 1, multiply by the reciprocal, cos u over 1. I have a common denominator. It's all over 1, so technically this is sine times sine. It's another way you could write sine times sine. Sine squared. When we write our squared, we write it in between. Plus, this will be cos squared. Okay. So we've managed to change things to sine and cos. We've managed to write things as a single fraction, because technically, if I wanted to, you could say this is all over 1, but that's not necessary. But I still haven't got them identical. my right side is 1, my left side is sine squared plus cos squared. And that was one of our big ideas from the previous unit. Sine squared plus cos squared, if the angle is the same, is always equal to 1. And now my two sides are identical, so I can write my final statement that my left side is equal to my right side. And I'm all done. So, what we're going to do for the next 15 minutes is to go back and do the ones that we missed. This page is excellent for slowly developing your skills. It starts off with ones that are super easy. It ends off with ones that are super hard. Okay? You can choose to do them on paper, or if you'd rather work in groups and do them up on the whiteboards, you can do that. And yeah, so we'll do that for the next 15 minutes.